Yesterday we talked about the protons and the neutrons having the same mass but having different charges. And so today what we wanted, and we talked about the atomic mass having being a unit that was designed specifically for atoms and molecules because the gram is too small. So the mass number is equal to the mass of the nucleus. And that is because the nucleus contains the protons and the neutrons. And the thing is that since the protons and the neutrons each are worth 1 AMU, the mass number does not have any decimal points. It's whole numbers, 1 AMU and 1 AMU. So if the protons and the neutrons are each 2, then the mass number, the mass of the nucleus, is 4. And it's a whole number. So next, we're going to look at the 5 formulas, Miss Paxton's 5 formulas that I came up with, which gives you everything that you need to know for this unit. Everything you need to know. All right, so where would this go? Periodic table. And we're going to use this in conjunction with a periodic table box. So let's draw that. Thank you. So the periodic table box that I'm going to draw is carbon. All right. Here we go. All right. So the first thing I'm going to do is atomic number, and I'm going to draw my atomic number here, which is going to be 6 for carbon. So let's label that. This is going to be the atomic number. And the atomic number for carbon, 6, is also the number of protons. Next, the atomic mass rounded off is equal to the mass number. Oh, wait, here, mass number, mass of nucleus. Nucleus contains protons and neutrons. So the mass number is the protons and the neutrons. Well, where do I find that? Right here. This is the atomic mass of carbon, 12.01. And so this rounded off is 12, and that is the mass number. And the last thing we're going to put in our box here is the C for carbon, and that is the element symbol. All right? So now we would take this atomic mass and we would round it off to 12. So the mass number is equal to the number of protons plus the number of neutrons. But we have the number of protons, so we can now find the number of neutrons. I take 12, I subtract 6, and that gives me 6 neutrons. So this carbon atom has 6 protons and 6 neutrons. Now, for electrons, my number of protons is equal to my number of electrons if the atom is neutral. Okay, if the atom is neutral. For our purposes, every atom that we are working with in this chapter is neutral. We will not work with any atoms that have charges. If we did, you would see a charge like -2 or +3. There would actually be a positive or a negative and then a number. That's how you'll know if there's a charge. If you do not see a charge, then it is neutral. And for our purposes, I am telling you now that until the next test, everything that we work with is neutral. So you don't even have to look, all right? Because according to the pacing guide, what we're doing now, everything is neutral. Normally I teach ions now because it's a good time to do it. So does Miss Fox, but we're not going to do that, all right? We're just teaching neutral, all right? So everything is neutral right now. All right, so let's look at a problem where we're going to use these 5 formulas, all right? And it'll be similar to the one you're doing for homework tonight. So we're going to turn over and we're going to go to example 1. We're going to skip the top section for right now. Example 1, find the number of protons, neutrons, and electrons for neon So what I'm going to do is I'm going to put the box for neon here. You do not have to, but I'm going to do it just so that you have it because, you know, you might be close to a periodic table. All right. So here's neon. Here's my atomic number, and here is neon's atomic mass. So number of protons. So we're going to go back. And how do I find the number of protons? It's the atomic number. Well, where is that? I go down and I look at my chart and it says atomic number right here. So I go back over. So atomic number, 10. Everything you need to know is right there. Okay, next. Number of electrons. Protons equals electrons if it's neutral. Is it neutral? It is. Two ways you know. One, there's no charge, and two, I told you it was. They're all neutral. So protons equals electrons. So easy. Next. Sorry, neutrons. Okay, neutrons, right? So I go back over here and I see neutrons equal mass number minus protons. Well, where do I find the mass number? Here, mass number, the atomic mass rounded off. Where do I find the atomic mass? Here, atomic mass, right? I take the atomic mass, I round it off for the mass number, and then I subtract the number of protons. Okay. What? Yep. So I take the atomic mass, I round it off 20. I subtract the number of protons, 10, and I get 10. So 10 protons, 10 electrons, and 10 neutrons. Is it always like that? No. All right. Let's try cobalt. You try cobalt. I'm going to put up the symbol. The box. Okay, so my protons equal 27. My electrons equal 27. And my neutrons equal, I take 58.93 and round it off, so I get 59, minus my protons, which are 27, and that equals 32. Questions? All right. Now, but sometimes it works out that the box on the periodic table is not the right numbers. And that's because, remember when Dalton said, atoms of the same element are all the same. And then I put a little asterisk there and I said, today we know this is not true due to isotopes. Right. So let's find out a little bit about isotopes. So now we're going to go to the top of the page. And before we start this section, we want to look at this isotope notation. And this isotope notation, which you see here, here, and here, and in this isotope notation, 12 is the mass number. All right? Okay, so now let's look over here at C12. So we know 12 is the mass number, and that tells us that we have 6 protons because we always have 6 protons in carbon. And So 12 minus 6 is 6 neutrons. So 6 plus 6 is equal to 12, a mass number of 12. So now let's look at carbon 13. So we have a mass number of 13. We have 6 protons. 12 minus 6, 13 minus 6 is 7. So there are our 7 neutrons. So 13 minus 6 is 7 neutrons. Next, we're going to look at carbon 11. So carbon 11, Colton, stop talking, is 6 protons. Colton, that's Colton. Colton, you're still talking. So 11 minus 6 is 5 neutrons. So 6 plus 5 is equal to 11. So each one of these samples are different because they have different masses. Okay? They have different masses. So one of these, 13, yeah. Oh, wait, what's happening here? Right, I did. Let's go back here. Let's do this. 6 plus 7 equals 13. How's that? Much better, right? Much better. Oh, there you go. Okay. They were right, but they just weren't consistent. We like it to be consistent. I like that consistency. Okay? So if we look here, our mass numbers change. So we have one that's heavier than 12 and one that's lighter than 12. They all have 6 protons, but they have different number of neutrons, which makes them different samples. Are they all carbon? Yes. But each one of these samples is a little different. Now, we're not worried right now about why the atomic masses are different and have decimal points yet. We're going to learn about that on Monday. But for right now, we know that these samples, which have atomic masses rounded off to these numbers, these samples have different masses, all right, and have a different number of neutrons, okay? So let's go down. We're going to go down a little. You can never change the number of protons, so it's always neutrons, because if you change the number of protons, you change the element. Now, in nuclear chemistry, we do change the number of protons, but that's okay because we change the element's identity when we do that. So let's go down a little bit here and look at isotope notation. We have 2 different methods. The first is carbon 12, which you have seen. And in this method, this 12 is the mass number. Okay? And then another method is where we take this carbon, the same carbon, and we're going to put the 12 up here. So this, again, is our mass number. And then down here below, we're going to put the 6. What is the 6 for carbon? No. The proton. So it's the atomic number. So we're going to put the atomic number here. Now, the atomic number is basically optional for right now. But then why would we bother to put it here? So we bother to put it here because this is a nuclear notation. And remember, in nuclear chemistry, we have the ability to split that nucleus. So let me show you what's coming. We have the ability to split that nucleus, and you can see here, we take boron, which has 5 protons, and we remove 1. So we need to have that starting point. This is very easy. Don't worry, very easy. But see how it goes from 5 to 4? So we actually do pull off a proton. So we need that 5 there so we can show that happening, all right? So these are the 2 that we use where one has mass number and atomic number. So let's do example 3, and then we'll be done. We want to write both the isotope notations for the following elements. So first, we're going to do phosphorus. What is the symbol, the element symbol for phosphorus? P, not pH, as many of you put on your element quizzes. Okay, so Next, we're going to need the atomic number of phosphorus, which is what? Phosphorus, the atomic number. The atomic number. 15. So we're going to have 15 protons plus, they've given us the number of neutrons, so 17 neutrons, and that equals 32, which is what? The mass number. Mass number. Now, I'm going to take the mass number. I'm going to do this one first, here, up here. So I'm just going to take the mass number, and I get phosphorus 32. Now I'm going to do the second one. So where does that 32 go on this second one? On the top left. And what goes down below? The atomic number, which is 15. Okay, do the second one by yourself, please. Calcium. All right. Now, so this is your homework. Your homework looks like this. You'll be doing exactly the same thing. All right? You'll be taking the mass number, and you'll be finding the atomic number, the protons, electrons. If there's nothing there, then you'll be using the mass number that's given. If there's no mass number that's given, then you'll be using the periodic table. So you'll fill them in, fill one block in at a time to give yourself hints on where everything falls, all right? And you're writing the symbol here, okay? Yep, you're doing the... Is it a whole page? Yep. The more of these that you do, the better off you're going to be. Remember, you're learning your elemental symbols, you're learning your protons. The more of these that you do, the better off you will be, all right?